All right, so next we're moving on to chapter 9, and we're looking at principles of mathematical induction, PMI, sequences, and series. PMI and sequence. PMI and sequence. The principles of mathematical induction, PMI, was introduced in Unit 1. The 4 steps for PMI are: Step 1, prove the statement is true for n is equal to 1. Step 2, assume the statement is true for n is equal to k. Step 3, prove the statement is true for n is equal to k plus 1. Step 4, deduce that using PMI, the statement is true for all integers. I don't like for all integers here, unless you're going to say for all positive integers. I would prefer if you say for all what? Natural numbers. Example 1. Example 1 says a sequence U1, U2, U3 of integers is defined by U1 is equal to, so U1 is equal to 1, that is given. And UN plus 1 is equal to 2UN plus 3. That is so this means that this is a recursive sequence. We're to prove by induction that, so this is a statement we need to prove. I normally call this statement sort of like some function of n. This statement is UN is equal to 2 to the n plus 1 minus 3. Now, my first step is this. I'm going to say when n is equal to 1, P1 would be the statement. U1, which we already know, is equal to 1. So let's say, and now using the formula, so let's say that this is our left-hand side. Using the formula, U1 would be equal to 2 to the 1 plus 1 minus 3. So let's say that this is the right-hand side. So U1 would be equal to 2 squared minus 3. This would be 4 minus 3. This is 1. So U1 was given to be equal to 1. And now, using the formula, we also got that U1 is equal to 1. So we can say, therefore, Pn is true for n is equal to 1. We're to then assume that Pk, which is the statement Uk is equal to 2 to the k plus 1 minus 3 is true. Then we are required to prove that Pk plus 1, which is Uk plus 1, is equal to 2 to the k plus 1 minus 3. This is equal to 2k plus 2 minus 3. We're required to prove that to be true using the fact that Pk is true. Now, let's go back to that initial formula we're given. I'm going to change the color of the ink. The initial formula we're given is this. The initial formula we're given is this, that UN plus 1 is equal to 2 UN plus 3. So what that means is this, that UK plus 1 would be equal to 2 times UK plus 3. Do you agree? Do you agree? Let me know. So then this now becomes what? UK plus 1, utilizing that UK is equal to 2 to the K plus 1 minus 3 plus 3. We're going to get UK plus 1 is equal to 2 times 2 to the K plus 1 minus 6 plus 3, which is equal to 2 to the K plus 1 plus 1, and minus 6 plus 3 is minus 3. So U to the K plus 1 is equal to 2 to the K plus 2 minus 3, which is what we're asked to prove in the first place. We're asked to prove this statement, and we just did. So now I can say that PK plus 1 is true when PK is true. Therefore, Pn, which is that statement that UN is equal to 2 to the N plus 1 minus 3, is true for all N, which is an element of the set of natural numbers. So let's small it up so that we can see more of it. Just a little bit more. So this is example 1. So let's have a look at example 2. In example 2, we're told that a sequence U1, U2, U3 is defined by U1 is equal to 1, so that is given, and UN plus 1 is equal to UN over UN plus 2. Show by induction that for all N greater than or equal to 1, UN is equal to 1 over 2 to the N minus 1. So this is our statement we need to prove by induction, that UN is equal to 1 over 2 to the N minus 1. So I'm going to start by saying when N is equal to 1, P1, we're told, so U1 would be equal to 1. This was given. And U1 is also equal to, using the formula, 1 over 2 to the 1 minus 1, which is 1 over 2 minus 1, which is 1 over 1. So U1 would also be equal to 1. So this appears, therefore, Pn is true for N is equal to 1. Then we're to assume that PK, which is UK, is equal to 1 over 2K minus 1 is true. Then we are required to prove that PK plus 1, which is UK plus 1, is equal to 1 over 2K plus 1 minus 1. We're required to prove that. Now, starting with using that initial formula or the formula we're given for UN plus 1, using that formula, we can say that UN plus 1 is equal to UN, over UN plus 2. So UK plus 1 would be equal to UK over UK plus 2. But UK is equal to 1 over 2K minus 1. So this would be equal to 1 over 2 to the K minus 1 divided by 1 over 2 to the K minus 1, which is 1 over UK plus 2. That is what UK plus 1 would be equal to using that formula. So this becomes 1 over 2 to the K minus 1 divided by 2 to the K minus 1, 1 plus 2 times 2 to the K minus 1, 1 over 2 to the K minus 1 divided by 2 to the K minus 1 over 2 times 2 to the K minus 2 plus 1. So now what I have is, this is going to cancel that. So now what I'm left with is 1 over 2 to the K plus 1 minus 1. And so U to the K plus 1 would be equal to this. So we can double check and see if this is what we're asked to prove. It should be that UK, see here, plus 1, we're required to prove this. And using UK, we're able to do it. So now I can make my statement that PK plus 1 is true when PK is true. Therefore, PN, which is this statement that UN is equal to 1 over 2 to the N minus 1 is true for all N, which is an element of the set of natural numbers. Let's make it smaller that you can see more of it, or maybe all of it. Right, I don't think I can do any better than this.